LRDI set number 4. So this set is basically based on the concept of Venn diagrams, right? So in this question, what we have given is a survey which was conducted among 120 kids, right, to check their preferences for ice cream, chocolate and milkshake. So let us draw a 3 variable Venn diagrams first. Right, let us take this as ice cream, this is chocolate and this is milkshake. Since I do not have any particular data for the only ice cream, only chocolate or all three combination, so I will assume the variables for the particular case. Let take it as A, B, C, right, for the ice cream and chocolates but not milkshake, take it as D. Similarly, this is E, this is F, and for all three I will take it G, right? So put this Venn diagram into a box. Why? Because there is another variable N, which means the number of kids who do not like any of the three, right? So the summation of all these variables should be 120, right? So I have given two conditions. One is the number of kids who liked at most 2 is 3 times the number of kids who like at least 2, right? And the second is the number of kids who like only chocolate was more than only ice cream, which in turn was more than only milkshake. So only chocolate greater than ice cream greater than milkshake. Put it in this variable, I will get B is greater than A greater than C. Okay, let us take the second condition, at most 2 and at least 2, right? In spite of writing this A, B, C, D, E, F, G and N again and again, let us take the only kids who prefer only ice cream, only chocolate and only milkshake to be A, capital A, and the kids who like the 2 of the 3 items be B, take it as capital B. So capital B will be D plus E plus F. All three will be, take it as G only, and none of the three will be N. Let us take these variables as A, B, G and N. So the summation of A, B, G and N will be 120, right? Now as per the condition, at most 2 means none plus 1 plus 2, right? And at least 2 means who like 2 of the 3 items plus all 3, right? When I put this condition into the variables, I will get A plus B plus N is equal to 3 times B plus G, right? Now from the equation 1 and 2, I will get 3B plus 4G is equal to 120, right? This is a linear equation in two variables. I could easily solve this equation and get the possible value of B and G, right? And B and G has to be integer because these are the number of kids, right? The minimum, so start with the minimum value. Let us take B as 0. I will get G as 30. Now the next value which B will take is 4, and next is 8. So this will continue up till 40, because as 40 I will get G as 0, and B and G cannot take the negative values, right? Similarly, this will decrease with the value of 3, 24, 21 and so on, 3 and 0. So these are the possible values which this B and G can take, right? So from the given condition I could determine the possible value of B and G, and from here I will proceed with the set, right? So let us take the first question. So in the first question it says the number of kids who did not like either of the three items was 1/5 of those who liked exactly 2, right? So in variable terms this means this n is equal to b upon 5, right? So my n has to be integer again, right? So for n has to be integer, I will take those values of b which are multiple of 5, right? So from the given set of values 0 to 40, we can easily see that the possible values which b can take is 0, 20 and 40 only, so as to get n as positive integer, right? So corresponding value of n will be 0, 4 and 8, right? And for these particular values of b 0, 20 and 40, the values of g are, for 0 it is 30, right? And for 40 it is 0, and when you check for 20, by putting this value of b here as 20, you will get g as 15, right? So 30, 15 and 0. So these are the three possible sets of values which could hold for this particular question, right? So from my basic equation of a plus b plus g plus n is equal to 120, I could easily calculate the possible values of a for these three particular sets, right? Because I have to calculate the number of kids who liked exactly one of the three items, which is my a, right? So for this 0, 0, 30 case, the value of a will be 90. For the second case, the value of a will be 81, and for the third case, the value of a will be 72. So for these particular conditions, there are three values of a which could be taken. So among the options, I have only 81 available. So option B is correct for this question. Next question. If the number of kids who did not like either of the three items was less than those who liked only milkshake. So in variable terms, it says this n is less than c, right? And I know that it is given in the set that B is greater than A is greater than C, and from this particular condition I could write this C is greater than N, right? If C is greater than N, then A and B will be greater than N also from this particular condition, right? Now I have the basic condition which says this A plus B plus G plus N is equal to 120, right? I have to calculate the number of kids who did not like any of the three items could not be more than. What does that mean? It asks the maximum value of N. Okay, so to get the maximum value of N, what I will do, I will try to minimize the other three variables. Okay, one thing more, from the values of B and G, I could say that the minimum value of B plus G will be 30, 0 plus 30 is, and the maximum value of this summation will be 40, right? So from here I will take the minimum of B plus G, which is 30, right? A is summation of B plus A plus C. Okay, from here I will get A plus N as 90. Now you can easily visualize that the maximum of N will be 21 only. Because why 21? Because when I distribute this 90 such that this equation holds true, so what I will give 20 to each of the four variables, and I will give 4 to B, 3 to A, value of 2 to C, and 1 to N. You can see as this plus 4 plus 3 plus 2 plus 1. So from here you will get the summation as 90, and the maximum of N is 21 only. So the correct option for this question is option C. Let us take the next question. It says that if each of the kids liked at least one of the three items, what does that mean? That N equal to 0, right? And the number of kids who liked only chocolate was 36. So the only chocolate was 36. The value of B is given as 36. The number of kids who liked ice cream was equal to that of those who liked chocolate. So I have to calculate the number of kids who liked ice cream could not be more than. So basically I have to calculate the maximum value of this, the maximum value of the kids who liked ice cream, right? That is my A plus D plus E plus G. Okay, so let us write the number of kids who liked ice cream. Number of kids who liked ice cream is A plus D plus E plus G is equal to that of who liked chocolate. The chocolate is B plus D plus G plus F. So G will cancel out and D will cancel out, right? So A plus E is equal to B plus F. Now I know that B is greater than A. So in order to hold this equation as true, I could easily say that if B is greater than A, E has to be greater than F in order to hold this equality, right? Now put the value of b. Okay, so I will get a plus e equal to 36 plus f. Moving back to my maximum case, which is to be calculated, can I write this as 120 minus b plus f plus c, right, from my basic equation? Why I write this expression as 120 minus this? Because from here I can reduce this expression into two variables only. So I have to calculate the minimum or maximum value, whichever the case may be, for the two variables only. My value of b is given as 36, right? So by putting the value of 36 here, I will get minus of f plus c. So in order to get this expression as the maximum, I will minimize this f plus c, because the minimum is this f plus c, the maximum will be the answer, right? So this will be 84 minus f plus c. So from here I cannot take this f plus c directly as 0. I have to check what could be the minimum value of c and f individual will take. So now move back to this equation. Can I easily say, by putting f equal to 0, I will get a plus e as 36, right? From here I could take the maximum value of a, which is 35, and e equal to 1, right? Now take the basic equation again. A plus b plus g equal to 120, and is 0 in this case, right? So I will take the maximum value of b plus g, because in order to calculate this c as minimum, I know that a is equal to b plus a plus c, right? So in order to calculate the minimum value of c, I will maximize the other value, and I know the maximum value of b plus g is 40 from the last question, right? So from here I will get a as 80, okay, and this b plus a plus c is equal to 80. I know the maximum value of a is 35, right, and b is given, right? B is given as 36. This is 35 plus c. Now this will give me the minimum value of c, which is equal to 9. So put this value of f and c here, I will get the maximum of a plus d plus e plus g as 75. Option B is correct. Move to the next question. It says if each of the kids liked at least one of the three items, same and equal to 0, and the other statements and other conditions are also same, right? So I have to calculate the number of kids who liked chocolate and ice cream but not milkshake. Could not be more than. So chocolate and ice cream but not milkshake. This is ice cream, chocolate, d plus g but not milkshake, that is d. So basically the question asks the maximum value of d. Okay, So other conditions are same as per the previous question, right? So what I will do, the D lies in my capital B, which is equal to D plus E plus F, right? So in order to maximize this D, I will minimize this E and F, or simply I can say that I will put the values of E and F from the previous question, because the other conditions are same as the previous question only. So the value of E was 1, F was 0. Minimum value of E is 1, F is 0. B plus G, this maximum was 40, right? So to get this B plus G as 40, the value of B was 40 and G was 0. So from here I can write D plus E plus F plus G is equal to 40. G is 0, F is 0, E is 1. So my D maximum will be 39. Option B.